You ever wonder how your streaming service just knows the next movie you're going to love? Or how a search engine can give you a straight-up answer to a really complex question, not just a bunch of links? Well, behind all that magic are these powerful, invisible systems that are busy organizing our entire digital world. Today, we're going to pull back that curtain and look at the technology that makes it all tick.
Look, our digital lives are just swimming in an ocean of information. It is a massive, tangled web of facts and figures and files. For a computer, trying to make sense of this mess is like trying to read a library where someone just dumped all the books into one giant pile. So how do we possibly bring order to that chaos? How do we turn all that raw data into actual, useful knowledge?
Think about this for a second. You go to a search bar and you type, "Who was president when the team that won the first Super Bowl was founded?" You don't get a list of links to figure it out yourself, you just get the answer. This isn't just about matching keywords anymore. There's something way smarter going on behind the scenes. And that's exactly the mystery we're going to solve.
The secret is something called a knowledge graph. And at its heart, it's a way of organizing information that kind of mimics how our own brains work. It doesn't just store random facts in isolation. It focuses on the connections between them. It actually maps out a network of real-world things and, crucially, how they all relate to one another.
Okay, so the first building block is super simple. It's called a node. A node is just a thing, an entity. It could be a person, like Leonardo da Vinci, or a place, like Paris. It could be a product or even an abstract idea, like climate change. These are basically the nouns in our big web of knowledge.
Now the second building block is the edge. And this is where the magic really starts to happen. An edge is the relationship that connects two nodes. It's the verb that gives context to our nouns. See, it's not enough to just have Leonardo da Vinci and Mona Lisa as two separate things. The edge, painted, is what connects them and creates an actual piece of knowledge.
And here's where it all snaps together. So you can see here, we've got a patient node. It's connected to a disease node with an edge that says diagnosed with. Then, that disease node is linked to a symptom with an edge that says includes. All of a sudden, we don't just have these separate, isolated facts. We have a connected story that a computer can actually understand and even reason with.
You know, this is a huge leap from how we used to store data. Traditional databases are like these really rigid spreadsheets. They store raw data in tables, and if you want to find a connection between different tables, you have to run these complex queries. But with knowledge graphs, they're flexible. They're like a web. The relationships aren't something you have to hunt for. They're baked right into the structure itself. It makes finding connections incredibly fast and intuitive.
Google actually captured this whole paradigm shift perfectly with this one simple phrase: things, not strings. The goal is no longer to just match a string of text, the words you type in. The goal is to understand the things those strings represent, the actual people, places, and ideas, and that whole web of connections between them.
And listen, this isn't some abstract, futuristic idea. Knowledge graphs are already deeply woven into the digital tools you and I use every single day, and a lot of the time, you don't even notice. So let's just look at a few powerful examples.
I mean, seriously, the applications are everywhere. We're talking about those handy info boxes you see in your search results, the movies Netflix just happens to suggest, the fraud alerts from your bank, and yeah, even the brains behind assistants like Siri and Alexa.
When Google rolled out its knowledge graph way back in 2012, it completely changed the search game. By understanding that France is a country and capital is a relationship, it could find Paris and give you a direct answer, right there in a neat little box packed with related facts. It started to understand the meaning, the intent behind what you were actually searching for.
Recommendation engines have this classic problem called data sparsity. Basically, it just means you've only watched or bought a tiny fraction of all the stuff that's available. Knowledge graphs help solve this by connecting you to a movie not just because of its genre, but maybe because of the actors or the director or other movies that director made. By mapping out all these complex relationships, they can make these uncanny suggestions that you'll probably love.
Now, this same concept has life-saving applications. In medicine, critical information is often stuck in different places. We call them silos. Knowledge graphs can connect it all. Research papers, patient data, genetic information, drug trials. This unified view helps researchers spot things like new drug targets and can even suggest using existing drugs for new diseases. It can dramatically speed up the whole discovery process.
And in the financial world, they're an absolutely critical tool for security. Fraudsters create these really complex networks to hide what they're doing.
But by mapping all the hidden connections between different accounts, IP addresses, devices, and transaction patterns, a knowledge graph can spot these sophisticated fraud rings that would be totally invisible if you were just looking at one transaction at a time.
Okay, so we've seen how powerful they are right now, but their biggest role might actually be what's coming next. With this huge explosion in artificial intelligence, a really crucial question has popped up. How do we make AI smarter, more reliable, and, more connected to reality?
This is where knowledge graphs become absolutely essential. They basically act as a factual backbone for AI. They give large language models, or LLMs, a structured source of truth, grounding them in reality. And this is so critical for reducing what we call AI hallucinations, when an AI just confidently makes stuff up. By plugging in a knowledge graph, AI agents and assistants become way more accurate and trustworthy.
So how big of a deal is this? Well, the industry has definitely taken notice. Just look at this number, 80%. What do you think that represents?
Well, according to the research firm Gartner, by 2025, a massive 80% of all innovations in data and analytics will use knowledge graphs in some way. So this isn't some niche tech anymore. It's becoming a fundamental piece of our entire data infrastructure.
And that kind of leaves us with this one final, really fascinating question. From search engines that actually understand us to AIs that can reason with facts, we have only just begun to scratch the surface here. What new discoveries, what new services, what new level of understanding becomes possible when all the world's information is no longer just a tangled web, but becomes a truly connected brain?